Hello everyone, welcome to the Gilbert tutorials. My name is Senyojo Gilbert and I am from Makere University. I do computer science. This is my name, okay? I do computer science. So today I'm going to teach you how to build a program to calculate square roots very quickly, okay? But first of all, I want to point out a few things. There are ways of calculating square roots without building a formula yourself, okay? In Dev or C programming, we have a library called math.h. It has special functions, including a function to calculate square root. So in your main function, you can call this function. Now this is gonna be a float, so it's a percentage. I call this function by saying sqrt. Sqrt, those are the keywords, okay? Square root of 5, and you run. All right. To 2.23. It's very fast. 0.16 seconds. Okay. So that is your method that is inbuilt for you in C programming. But all right, I want to build one myself that doesn't involve calling methods. So maybe you have an assignment and you are looking on YouTube for a way to find the square root of 5, or to build a function to find the square root of 5 without calling the method for square roots in the main library. Okay, so I'm going to teach you that. If you stick around, I'll also show you another better way that you can build one that is more complicated, not so complicated, but okay, it is faster. All right, this one is a layman way of building a program for square roots, but it is acceptable for study purposes. Okay, so I'm gonna say float number is equal to 5. I'm also going to say float value and root. Alright, so I'm going to use a for loop. For root is equal to 0, root less or equal to number plus 1. Why do I add 1? Someone, do you know why we add 1? And what am I going to be doing? I'm going to be incrementing by a small number. You can increment, the smaller the number you're incrementing with, the more accurate your answer. So, alright, why was I adding 1? You see, these numbers, there are values like 0.3. The square root of 0.3. Alright, let me say 0.9. What's the square root of 0.9? Alright, let me get my calculator here and I show you. Calculator. Let this be quick. I wanted to find the square root of a number like 0.16. Oh, that is not 0.16. 0.16. Oh, what's wrong with this? Let me use my keyboard. 0.16 square, 0.4. So 0.4 is bigger than 0.16. So if you make your root begin from 0 up to the number, you'll never reach the square root of 0.16, because you get from 0 to 0.16. The computer will not find 0.4 in that range. So you have to increase up to 0. You have to add a 1. It sounds that it spoils your loop. It won't. It will be actually the solution to your problem. Okay, I hope you understood what I said there. So I'm going to say value is equal to root times root. Okay, I'm going to check if my value is greater or equal to my number. To see if it is greater or equal to, then I just say that is my square root. Simple as that. I just say that is my square root. Right? Now I have to break this. Why do I break? If I don't break, the loop will go on and on. Alright, if I just remove this one and I run my program. Oh, come on, I want to close you as quick as possible. They say it can damage a computer. See? They say I am not a person who said it, alright? So I have to break this statement so that it runs steadily, alright? Steady. 2.23. Now look at this. This compilation time. 5.81. You see, this is out of time. I want a program that does a lot in a small amount of time. Plus, I want this time to be very short. See, this one is 0.167 seconds. And this one, on the other hand, wow, this is some other nonsense. Okay, so I want to make it run very quickly. Now, for those of you who came here for an assignment, I think that is pretty much everything you need to know. This is what you need to do to build a program for a square root. Now, if you increase the number of zeros here, your accuracy increases, alright? Your accuracy increases. What do we have? Come on. 2.2367. See? This is more accurate, but it's also not very accurate. It is just more accurate, okay, than the previous one. Square root of 5. 2.2360, but the rest are not that accurate. It says 7. This one was saying something else. This one was saying 7.9, okay? So we want a more accurate one, and it runs quickly. So I'm going to teach you how to build a program that runs very quickly. So let me show you. Alright, let me put some lines here. Program for square root running quickly. Alright, simple as that. So I'm going to change a few things. First thing I'm going to change, let me remove all of this loop. I don't need this loop. Why isn't it disappearing? Why? I'm going to include a variable here. Why? As I said, accuracy is dependent on this increment. So if I say y, okay, so I'm increasing by y. If I initiate my y with 1, begin from 0, 1, 2, 3, counting numbers, okay? So I'm going to create a loop here for, oh, that's my loop actually. If value is equal to double equal sign is equal to number exactly equal, right? What do you do? Printf, print format, %f is square root, right? What is %f root? And you break. So a number like 9, which is a perfect square, you have no problem with it. You have no problem with it. Oh, I didn't add what? I didn't add this one. Sorry. See? 0.1. 3.000. Okay, now I'm going to improve my function by allowing it to calculate numbers like these ones. Those ones don't have a perfect square, okay? So I'll cater for them by saying else if value is greater than the number. So it has reached the square root, but it is not actually the actual answer, right? What do? First thing to do, you go back, alright? So if maybe your number is 15, square root of 16 is 4, so I think the first value you get is 3. Then you say 3 times 3, 9. 4 times 4, 16. Go back to 3, okay? Go back to 3. So say root minus equal to y. Subtract this value, alright? So it will go back to 3. What do? change y. All right, change y. So if your y was 1, multiply 1 by 0.1. Okay, so now you'll be adding plus 0.1 plus 0.1 plus 0.1. So you reach maybe like 2.8, I mean 3.8 there. So when it goes to 3.9, 3.9 is not giving you 15. Again, multiply by 0.1. So it says 3.81, 3.82, 3.83. And like that, we get our answer more and more accurate. Okay. Now, what else? See, here, remember that the square root of a number like 15 will never be exactly equal to, you will never be accurate. It will always be a round off. Okay. So here I'm going to add an or statement. I'm going to say, if my accuracy, maybe I've looped and looped like 10 times or 5, and I'm reaching a point where my y is less than 0.001, that's enough. That answer is good enough for me. So I just say that. You can even use equal sign to work. You can even put equal sign. Alright, let us see. Do I have a mistake? Hope I don't. If I don't, I have to repeat this entire thing. This entire tutorial. 3.872908 in 0.13 seconds. That is fast. Let me see, where is the calculator? Let me get you a calculator and we check if our answer is fine. What are we finding? We're finding the square root of 15. Okay, square root of 15. 3.8729 and something there is not accurate, but that is accurate to some good number of decimal places. If you add 2 zeros here, what shall we have? How accurate will our answer be? Three 3.872983. That is accurate. Okay, you can see the previous one was not that accurate. Okay, this one was saying 2908. Okay, so that's our quick tutorial. Thank you for watching, guys, and have a nice time.